Hi, my name is Yak, and today I'll be proving congruency in triangles. So, before we're able to prove congruency, we must be able to define it. What it means is when there are two shapes are exactly equal in size and shape. Congruent sides or segments have the exact same length, while congruent angles have the exact same measurement. For any set of congruent geometric figures, corresponding sides, angles, faces, etc. are congruent. Note that congruent segments, sides, and angles are often marked, so they will show you when an angle, side, or measurement are actually congruent. Now, here are some examples to show how to prove congruency. Right here we have Ms. Baker's smartboard that she has in class. As you can see, I made a few rough assumptions of how long it is. So as you can see in the bottom and the top, they're both congruent. They're both 2 meters, and on the sides they're 1.5 meters. And the way we're able to make a triangle out of these two, we just split the rectangle in half. We split the smartboard in half, as you can see that right there. But we have them in half. But how can we prove congruency? We consider two triangles, but we should be able to prove congruency. So as you can see in the triangles, they actually share a reflexive property, and that reflexive property is 2 meters as well. And as you can see, when there are two triangles, they are actually congruent because if you look at it this way, they share the reflexive property means that they use that same angle, that same side. My bad. So since you use the same side, it's 2 meters, and on the side it's 1.5, and on top it's actually 2. Same thing with the other one. The reflexive property is 2. On the right it's 1.5, and at the bottom it's 2, making them congruent because they are exactly equal in size and they are exactly equal in shape. So here's another example of how we can prove congruency. Now remember, congruency can come in large objects and it can also come in small objects. Last time we had a large smartboard. This time we have just a small packet of staples. And as you can see, it's also a rectangle. And in the rectangle, it's actually the exact same thing as the example that we viewed before. They have both the right side and the left side are congruent to each other, and the top and the bottom are also congruent to each other, but the top and the bottom are not congruent to the right and the left. So how do we make a congruent triangle, you might say? We do the exact same thing. We cut it in half by putting a line from the bottom left to the top right. From that way, we create two triangles, making them exactly congruent. And how are they congruent? Exact same way that I proved it before. Since we use our reflexive property of the line that we created to cut it in half, the bisector that we created, that's actually the reflexive property. So since it's cut in half, we just use the same measurements. Let's say it was the top that was 2, the bottom 2, and the right and the left side were 1.5. When we cut it in half, and the bisector is 2, then we use a 2 with the bisector. The top is 2 and the right is 1.5, making it an isosceles. And if in the other triangle, it's the exact same thing. The reflexive property is 2, the right is 1.5, and the bottom is 2, making also another isosceles triangle that is congruent with the other triangle because they're in exact shape and size. To cap it all off, here's our final example. We're going to use tissue box. Now, let's imagine this is 6 inches, this is 4, 6, and 4. So these two are equal, these two are also equal. So now, we'll create a bisector. And all we can just create a bisector really is about just creating a line through it, Just making a line from here to there. Right here. And once we do that, I'll try to do it right now. Now that we do that, we have two triangles here. And let's imagine that this line is also 6 inches. So this line in the middle between this and this is 6 inches. These two are 6. these two are 4. Now, let's focus on the triangle that's going to be created here. It's going to be 4 on one side, this one is going to be 6, and this side is going to be also 6. So it's a 6-inch, 6-inch, and 4-inch triangle, making an isosceles. Now, we have one triangle, but we want to prove congruency. So how can we check that these two are going to be the same? Well, take a look at this. Thus, this one is also going to be 6 inches, 6 inches, and 4 inches, making it congruent because it's the exact same shape and size. They are equal in they're equal in size, and the sides are also the same, and they're also equal in shape. And if we would like to measure it, the angles will also be the exact same on each side of the triangle.